Hello, how are you? I welcome you today to our tutorial, which will go through physics concepts on the topics that we've learned in class, such as densities for grade 10 and length for Form 1. So please, as you prepare for your tests, add this video to your study list. It will help you to remember all the concepts that we've done in class. I'm Sir Fredrick.Jr. and this is the tutorial. Let's see, first start with density. Okay. So what is density? What do you know about density? So density, we use the symbol rho. It looks like a sleeping P, but sometimes we can also use D. Okay. What is the SI unit? Is kilogram per meter cubic. Okay. Then other units of density. Other units. This includes grams per centimeter cubic. Okay. So as a student, you need to know, you need to have a skill moving from one unit to another. So how can you move from kilogram per meter cubic to grams per centimeter cubic? Oh well, the conversion unit is that 1 kg per meter cubic. It just give you 0.001 grams per centimeter cubic. Then 1 gram per centimeter cubic, it is just equal to 1000 kilogram per meter cubic. Now, one of the students argued to say, sir, how come 1 kg is giving us 0.001 grams per centimeter? All right, so let me try to show you how this came up. So if you have 1 kilogram per meter cubic, we know that when you are moving from grams going to kg, you divide by 1000, the conversion factor. When you have kgs, you are converting them back to grams, you multiply by 1000. Okay. Well, then we know. Then when it comes to volume, we know, okay, so if this is our mass, then volume, we know that when you are moving from centimeter cubic going to meter cubic, you're supposed to have 1 million. So you always divide the unit given in centimeter cubic by 1 million. Okay. Then if you are moving from meter cubic, you multiply by 1 million. Okay. So take this into mind. So let's now convert 1 gram per meter cubic into what? Into grams. So we know that we are having kilograms, so we are going to grams. So we multiply it by 1000, okay, to have grams. Then we know that we have meter cubic. So 1 meter cubic into centimeter, you multiply it by a million. Okay, so what do we get when you do that? Okay, so I'm getting, if you punch on your calculator, it will literally give you, okay, so grams, here centimeter cubic, so this will just give you 0.001 g per centimeter cubic. So this is where this value came from. So vice versa, when you are also converting grams per centimeter cubic, you are taking them into kilogram, you do the same. So let me demonstrate that. Okay, so I'll keep this right here for future use. Keep it there. What if we have 1 gram per centimeter cubic, and we really want to convert this into kilogram? So what do? We know that 1 gram to centimeter cubic, we divide by 1000. Okay, then over, because this slash means divide by, so 1 centimeter cubic, taking it into meter cubic, will divide by the conversion factor 1 million, just like that. So when you divide 1 by 1000, you're going to have 0.001 over, when you divide that, you are going to have 1 divided by 1 million. Okay, it will just give you 0.00000, okay, 5 zeros, okay, 1. Okay, just like that. This one, sometimes if you want, it is just 1 times 10 to the power negative 6. Okay, this is same as that. So now when we divide this, what do we get? So 0.001 divided by 0.0000. Okay, I should have 5 zeros, then 1. What does that give me? Okay, so we are converting this one into kg, this one into meter cubic. So this just give me what? This just give me 1000 kg per meter cubic. So this is how these numbers came with. So now when you are handling problems with density, you don't need to go through all this pain. Okay, so I'll give you a quickest method that you can use. So method 2. So you use that Samlenger's cycle. Okay, so when you are moving from grams per centimeter cubic, and you are going to the unit density of kilogram per meter cubic, what do you need? You just need to multiply. Okay, so here by 1000. Okay, this side, when you are moving from kilogram per meter cubic to grams per centimeter cubic, you also multiply by 0.001, then you convert. Okay, so go ahead and pause the video, convert these following units of density. Okay, 4 kilogram per meter cubic to grams per centimeter cubic, then 6 grams per centimeter cubic to 2 kilogram per meter cubic. Try, pause the video and try that. Okay, so if we get 4 kg 4 kilogram per meter cubic, and using our simplest method, so 4 times 1000, it will just give us 4000 kilogram per meter cubic. Done. Okay, so that's number one. So number two, if we use our method, so 6 grams want to go to, oops, okay, so since we are moving from kilogram per meter cubic, we are moving from higher unit, so we'll multiply by 0.001, and if you punch that on your calculator, you're gonna have 0.004 grams per centimeter cubic. Okay, so since we have grams per centimeter cubic and we are going to kilogram per meter cubic, if you look at our conversion cycle there, so we'll just multiply by 1000. So this by 1000 is going just to give us 6,000 kg per meter cubic. And this is how you do it in the exam. So you don't need to go with all those things that I was trying to clarify you with to you, but you can just go direct if you are asked to. And I need to remind you that when you are handling the problem for density, it's not always you are converting the units unless you are asked to do that. Okay, now let's define this. Okay, what is density? So I'm going to clear a board. So what is density? So density is the mass per unit volume. Just like that, simple definition is a unit, density is a mass per unit volume. Just that. Okay, now for you to calculate density, you need to have these two physical quantities. You're supposed to have mass of an object, and you're also supposed to have volume of an object. So in class we learned how we can find these things because I was preparing for you to come and handle these problems. Okay, so I'll just go straight away to how to find density. So let's start with the density of regular solids. So we have a question here saying calculate the density of the following object which is placed on the electronic balance. So we have different object that was in which all its mass were determined using what? The electronic balance. So as usual, for you to solve density, you need to have volume and the mass of an object. Okay, so our job here, we're first going to solve the volume of each object given, and then go ahead and calculate density. We know the formula of density, that it is density is mass over volume. Okay, so let's begin by solving first the volume of the object A. So volume of the cone is determined by this formula, pi squared height, and we know that the height given to us is just 5 centimeter. Okay, so we'll go ahead and substitute. So that times 3.142 value of a pi squared times 5. Okay, so what do we get? You go ahead and do it on your calculator there. So this will just give us the volume of 16.44449. So this will just round it off to 16.5, or you can also leave it to the whole number as 17 centimeter. Okay, cubic. This is just fine. Okay, so now you have your volume. You can now proceed and solve what your density. So density is equal to mass over volume. So according to the data given, mass of this cone is just 500 grams. There is no need to change the SI unit here. Then the volume calculated is just 16.5 centimeter cubic. Then we'll substitute in the formula. Okay, 500 divide by that. Go ahead and solve on your calculator. Okay, so this, if you punch, okay, so it just give us density of that 0.3 grams per centimeter cubic. Okay, so once again, there's no need for change unless we ask you what is this density in kilogram, and you apply that principle. You just, every time you are moving from grams per centimeter cubic, what do? You always multiply that given to 1000. So if we were asked to change this into kilogram per meter cubic, it will just be that. So 30.3 multiplied by 1000, it will be just 30300 kilogram per meter cubic. Then this is the density in what? In kilogram per meter. All right, so we go to part B of a question, in which we have a cube. So the volume of a cube, we know from the table that we wrote, the table formula for finding volume. We know that volume of the cube is just L3. So this means that 7 times 7 times 7, that, or rather 7 times 7, okay, that. And what do you get with that? So I found volume to be 343 centimeter cubic. So now, according to other data, what is the mass of this? Is reading as 200 grams. So we can proceed and solve for what? Can proceed and solve for density. So density, mass over volume. So that just gonna give us 200 divided by 343, okay, centimeter cubic. So what do we get? So on your calculator, go ahead and find the answer. 43, it will just be 0.58 grams per centimeter cubic. Done. That's how we solve. So it is very much important in physics, you show how you solved your problem, because if you just go and plug in the answer, we'll get less marks. Okay, now this makes us to go ahead and solve part C. So I'll create a space here for C. Okay, so let me just move these two diagram remaining. Okay, let me just copy them and paste them here so that we solve them just right here. Okay, so begin with this one will be this side. So let's go ahead. We know that the volume of the block, or rather a rectangle, is L times B times height, and we know that from our data given, height is just 6, then length is just 8 centimeter. Okay, then the breadth given is just 4 centimeters. Okay, so go ahead and plug that. So 8 times breadth 4 times a height of 6. What do we get now? So 8 times 4 times 6. This will just give us the volume of 192 centimeter cubic. Okay, then on the electronic balance we have the mass of 400. We have the mass of 400 grams. So density is just mass over volume. You see how I'm solving? I'm following everything that I need to follow. So that's what we are looking for. Even you need to do that. So density is just mass of 400 over 400 grams over 192 centimeter cubic. So I'll write the answer there. So 400 divided by 192. So this just gives us 2.08 grams per centimeter cubic. Okay, this you can raise it to 2 decimal place, to 1 decimal place. That will be just that, meter cubic. And this is our answer there. Now let's solve the last one. If you want to try, you can pause the video and go ahead and solve that. Okay, then let's begin. So let's correct the data first for this one. So mass given or mass reading on the electronic balance, the mass given is just 300 kilogram. Okay, then we've been given the diameter. Half of this small spherical ball is 5 centimeter. So what will be the radius? We know that the radius is the distance from here to there. Okay, so radius, so half of 5 is just 2.5. So the radius given is just 2.5 centimeter cubic. But look, we are having the different SI unit here. So what do we do? First, let's go ahead and solve the volume in centimeter cubic. So we know from the formula of finding for volume. So volume of a sphere is 4/3 pi radius cube. Okay, so let's go ahead and substitute this. So 4/3 times 3.142 times radius of 2.5 cubic. So let's go ahead and find that. So punch on your calculator. Times pi, okay, times 2.5 cube. Okay, so I found the volume of 65.5. I've rounded off centimeter cubic. All right, so now the job we have two different units. Mass is in kg, while the volume is in centimeter cubic. So the puzzle here is that we need to make one of the unit follow the other. There is no way we can solve kilogram per centimeter cubic. So we'll make the volume to follow to go to meter cubic. or the other way around. So let's make the volume into meter cubic. So let me create space. Okay, so we know that 1 centimeter cubic is just 1 million 1 million meter cubic. I mean, okay, let me change that. So we know that 1 million centimeter cubic, it is just 1 meter cubic. So what about this which we have 65.5 centimeter cubic? What do we have this side? Okay, so we'll divide. So we're gonna x times 1 million is just 1 million x, just 1 million x. This 65.5 times 1, it's just that number. Okay, so 1 to remain with an x, so both sides will divide by 1 million, both sides by 1 million. Okay, so this goes x is z. Okay, so 65.5 divided by 1 million, it is just going to give me 0.0000655 meter cubic. Okay, so if you want, you could have just gone direct, you get the number and divide. Okay, so this is the volume that we've acquired. Now we are ready to solve for what? For density, and this density of ours will be in kilogram per meter cubic. So let me create space by compressing this. Okay, so keep that there. So now density, mass over volume. So we know that mass given is 300 kg over 0.0000655 meter cubic. Okay, so what is that? So if we divide that, indeed I found the density of 458015552.672. okay, so now this number is too big to write, and this answer is also correct. Okay, but you apply scientific notation. Oops, I'm changing that. Okay, so this one, if the point moves from there where it is 1 2 3 4 5 6, okay, so our density then will be 4.6. I'll round off that. I'll pick one, and to be 4.6 times 10 to the power 1 1 2 1 2 3 4 5 6 times 10 to the power 6 kg per meter cubic. Just like that. That's the correct answer. So this is how you'll be handling density of regular object. Okay, where you apply the formula for volume. Okay, now let's get to what is interesting now. What if we have been given to solve the density for irregular substances?